Hi everyone, and today we're going to explore natural hazards in Nunavik, a presentation by the Kativik Regional Government in partnership with the Centre d'études nordiques of Université Laval. At the end of this short video, you'll be able to know what is a natural hazard and which one occur on Nunavik's territory, how to assess the risk of a natural hazard, how to report a natural hazard if you observe one, and what is the Natural Hazards in Nunavik web platform. Natural hazards are the result of the destabilization of a physical environment in response to one or two more triggers. Those triggers can occur in many forms. They can be meteorological, such as precipitation, wind, heavy snowfall. They can also be hydrological triggers, such as flooding, river surges, and high waves. They can be geological, like earthquake, but they also can be from other origins, such as man-made destabilization of slopes that can occur during construction works. There are different categories of natural hazards. There are the mass wasting, hydrological processes, erosion, climatic, permafrost, but also earthquake. Let's start by defining some keywords that are important to understand what are periglacial processes. First, we have the geomorphology, that is the scientific discipline that studies the processes of landscape formation. So we have geo, that refers to earth, morpho, that refers to the form, and logi, that refers to the study of. Periglacial refers to the conditions, processes, and landforms associated with freezing climates, but that are not with glaciers themselves, so not the glacial processes directly. So we have peri, around, glacial environments. So if we combine those two words, the periglacial geomorphology is the study of landform specific to cold environments. There are landforms specific to permafrost, and these are excellent indicators of the sensitivity of the terrain and the amount of ice contained in permafrost in the ground. Permafrost is the term that refers to the ground that is permanently frozen. Permafrost is defined as soil or rock that is maintained at a temperature at or below 0 degree for at least 2 years. Permafrost on the land has two layers: the active layer, that thaws on the surface every summer and freezes back in winter, and the permafrost itself beneath, that is always frozen. In the mass wasting processes category, we have the landslide. A landslide is the downslope movement of mass of soil under the influence of gravity. In Nunavik, the most common type of landslide is active layer detachment failure. These landslides tend to occur near the end of a particularly hot summer when the thaw penetrates deeper than in previous year in the ground. This process is characterized by the thawed material over the permafrost that is sliding over the frozen ground. In the landslide category, there are also the retrogressive thaw slumps that are occurring in permafrost environment. The retrogressive thaw slump affect greater material thicknesses, and they develop over several years. This process is not common in Nunavik, and this is why we're not going to talk about it further. Gelifluction is the slow downslope flow of soil surface on the slopes. During summer, the thaw-water-lodged soil begins to descend on the slopes. It is the result of the creep of the thawed soil surface layer on the ground that is still frozen underneath. On those pictures, we can observe the gelifluction lobes on the land. Debris flows are rapid mass movements of rocks and or debris along a slope. Generally, debris flows are caused by a sudden heavy rain or by a rapid snowmelt. Can also be both at the same time. The water is absorbed by the debris, triggering a flow down the slope. Rockfall is also a rapid process. It is the relatively free falling of a newly detached blocks of bedrock of any size from a cliff or other very steep slope. They are related to factors such as erosion or weather conditions, particularly the freezing and melting of water in the joints and cracks in the rocks. Also occurring in Nunavik are the slush avalanches. They usually consist of a mixture of water, snow, mud, and boulders. Slush avalanches generally occur during a rapid melting of the snow and heavy rains. They can occur on very gentle slopes angles. Dry snow avalanche is the rapid flow of a mass of snow along a slope under the influence of its own weight or gravity. Snow avalanches develop in environments characterized by abundant snowfall, and such activity is especially favored in areas of steep slopes. Among the erosion processes in Nunavik, coastal erosion has a big place. The processes involved, such as the waves, currents, and winds, erode soils of the coast, carry them away, and deposit them far away from their original locations. Successive storms, or a particularly violent storm, can cause significant coastal and banks retreats. Storms waves cause the exposure of frozen ground, which thaws quickly in contact with water. Fluvial erosion, on the other hand, is the high river discharge that erode riverbanks. Fluvial erosion can also trigger other processes such as landslides and rockfalls along the banks. It is directly related to the occurrence of flash flood. Wind erosion is when the particles such as fine sand and silt are detached from the land surface by wind and are transported over long distances. A drought is a prolonged climatic period during which the value of precipitations is lower than the average recorded over several years in the region. A drought brings a decrease in the amount of water in soils and in sources of groundwater and surface water. Fires can occur in the natural environment, such as the tundra. They can cover large areas quickly. They can be caused by a natural event such as lightning or by human activities, and they lead to the destruction of vegetation cover and exposure of the underlying soils. A windstorm is a storm made by high winds, such as winds over 75 kilometers per hour, with little or no precipitation for several consecutive hours. A blizzard is a powerful and prolonged snowstorm, loaded with snow and drifting snow, usually accompanied by low temperatures and high wind. Blizzard can be very dangerous because it greatly reduces or even completely the visibility and causes what is called a whiteout. Lake drainage is when a lake drains completely and can be sudden and sometimes catastrophic. The main cause of lake drainage is erosion along channels, superficial or underground, interconnected by cracks filled with ice, called ice wedges. The lake drainage occurs during the high water snowmelt period, after a torrential summer rainstorm, by rapid coastal retreat associated with erosion by wave action, or by man-made activities such as a construction work that can disturb the ground. Coastal submersion is the flooding of low-lying areas along the seacoast during storm surge. High water levels, associated with high waves, pushes towards the coast by strong winds cause a coastal flooding and accelerate coastal erosion. A flash flood is a quick and sudden rise of stream or river water level, while a flood is the invasion of land by the water overflowing their channel. Flash floods are due to exceptional weather condition or by heavy torrential rain of a short duration. They can also occur during the snowmelt period behind an ice jam at breakup or during the catastrophic drainage of a lake. Floods occur after longer periods of heavy rainfall that rise the flow of rivers at very high stages. An ice jam is caused by accumulation of ice in a river that can form an ice dam. The river ice can be as much as 2 meters thick, while breaking of ice dam is called the breakup, can be triggered in two ways. One, the rapid increase in water flow creates pressure on the ice accumulation and breaks it, or two, the ice cover deteriorates locally due to the increased temperatures of the air and water. On another hand, ice push is the lateral pressure that is caused by the expansion of ice on bays, straits, and lakes. Sea ice is forced by waves and strong onshore winds to overthrust upon the coast. Generally, ice push follow a rise in temperature. Ice pushes also occurs around the shores of inland water bodies that are large enough to permit wind-induced movement of the ice cover. Among processes you can observe throughout Nunavik in permafrost, there are the frost blister. Their formation is related to the water flowing in the soil that concentrates at one place and forms an ice lens trapped under the surface of the frozen soil in winter. This frozen ground will swell and crack due to the pressure created by water. When the water lens freezes, it becomes the frozen heart of the moon. Normally, the ice melts during the summer, but sometimes it can last for more than a year. Icing are layers of ice that form either on the soil surface or in the bed of a river or a lake. They occur when freezing water outflows on the surface from beneath the ice cover in winter. The water pressure under the ice forms a domes that crack open and let water flow on the surface. The flowing water freezes quickly into ice at very cold air temperature. Thermal erosion is common in Nunavik. This process happens when running water comes in contact with permafrost. Water, that is warmer than the permafrost, erodes the frozen soil. Quickly, ravines may deepen and widen. Thermal erosion is made mainly by water flowing from snowmelt and rain. It provokes locally the fast thawing of permafrost. Thermokarst subsidence, or thaw settlement, is the slow and progressive process characterized by the downward displacement of surface material. It is associated with a loss of water upon thawing and its removal by either evaporation or drainage. Thawing can come from the heat generated by a construction or by industrial activity, which goes directly into the permafrost. The result is the thawing of the permafrost that supports the structure. Thermokarst subsidence or thaw settlement can affect buildings and roads. Thermo refers to heat. Karst refers to the landform resulting from the collapsing of the ground. Sub refers to the underground, and sidence is the settling of the surface. The more ice-rich the ground is, the more intense thaw settlement will occur as the thaw progresses in depth. The last hazard presented in this presentation is an earthquake. Earthquake is a motion of the ground surface, ranging from a faint tremor to a violent shock capable of shaking buildings. The tremors spread through the ground from the center of the earthquake. Earthquakes can have catastrophic effects on infrastructures and can also cause landslides, avalanches, soil cracks, and so on. Nunavik is particularly sensitive to climate change due to the presence of permafrost. This figure shows the climatic projection to 2050. The projected increase of the mean annual air temperatures suggests an increased temperature of 2.7 to 3.4 degrees. Here we have the permafrost distribution map produced in 2017 by the Center for Northern Studies. But climate change are not only going to have an effect on permafrost distribution. They will also have an effect on the footprint, frequency, and intensity of natural hazards. Due to climate change, we can expect a warming of permafrost due to the rising air temperatures, an increase of precipitations, an increase of the risks associated with the terrain's degradation, a deepening of the active layer, and an increase of instabilities on slopes, so more processes like landslides, thermal erosions, and so on. Increased precipitation combined with rapid snowmelt due to rising air temperatures could accelerate and increase the river discharge and cause more frequent flooding. These particular climatic conditions could also accentuate fluvial erosion. More climatic events, such as storms, are likely to increase coastal erosion and coastal submersion. Let's give a look at how to assess the risk of a natural hazard occurring in a community in Nunavik. First, we need to give a look at the particular context of Inuit communities. Inuit communities are exposed to natural hazards. The population in Nunavik is growing fast, and there is also a fast growing of infrastructures. There is also a sensitive environment because of the presence of permafrost, but also because there is a limited vegetation. It's sensitive to slope instabilities, and the processes are initiating fast. Nunavik's context creates a limited resiliency to natural hazards. The population is isolated and communities are located in remote areas with an access only by sea or by air. The material and human resources are also limited. The estimation of the risk level is depending on the degree of vulnerability of the element exposed to the potential natural hazards. The simple equation to determine the risk level is the hazard plus vulnerability equals a risk. The more the population is vulnerable to the hazard, the higher is the risk. Indeed, if there is a landslide, but there is no population living near the landslide, the population is not at risk. There is only a risk when the population is vulnerable to the hazard. The component we have to identify about the natural hazard are the hazard type, but also the frequency, so does it happen often, the speed of evolution, was it fast, the intensity, the duration of the impact, the spatial extent, so how big is it, and also look at the future probability that it happens again. For the vulnerability, we have to look at the exposure and sensitivity of the population. So, is the population at risk? What about the economy, the land use, the infrastructure, and the resources? If at any time or any moment there is a risk for the safety of the population or for infrastructure integrity, first contact your municipality or the Kativik regional government. And only if there is no risk for the community or for infrastructure, here are the steps to follow to report the natural hazards that you have observed on the territory. First, take a picture of the hazard and note the photo number. We want to see what you have observed. After, write the date. We want to know when this natural hazard was observed. Write your full name and contact information, so we can contact you if we have further questions. And also, it's really important to write the GPS coordinates of the hazard if your camera does not have a GPS. Or, if you do not have a GPS, send us details about the location where you observed the hazard. The last step is to note any other important details that you could have observed. In what kind of environment the hazards occur? Was it a slope? Was it a clay deposit? Did you see exposed ice? Anything. You can also give us input about the meteorological conditions the day of the hazards and any other meteo anomaly the week of the hazards. Once you have completed your report, you can send it to the Kativik Regional Government, to the Department of Renewable Resources, Environment, Land and Parks. You can send it to the Center for Northern Studies to this email address. And when officially launched, you can send your report on the Natural Hazards in Nunavik web platform that I'm going to present you in a moment. The Center for Northern Studies produced the Guide of Potentially Observable Natural Hazards in Nunavik. In this guide, you will find again the processes we discussed today and also more details about each of them. This guide was translated in Inuktitut by the Kativik Regional Government and will soon be available too. Here we are on the Natural Hazards in Nunavik web platform. This web platform was built to share the results of the project about identification of natural hazards in Nunavik, produced by the Center for Northern Studies in collaboration with the Ministère de la Sécurité Publique du Québec. On this website, you will find useful resources to learn more about natural hazards in Nunavik, but also where to download documents such as the Natural Hazards Guide on this tab, that you can consult either through a story map, where you can navigate through the different natural hazards processes in the different tabs, or download the PDF version of the guide here. On this tab, you will find the reports and maps that are available for each village. We discussed earlier how to report the natural hazards if you observe one on the territory. One of these options was to send it through the Natural Hazards in Nunavik web platform. To do so, you can just go on the Reporting tab here. This pop-up simply shows the contact information for each municipality in case you would have any concerns about safety. Otherwise, you can continue to the report file here. So these are the questions of the different steps we presented earlier. So there are the field to fill here with your contact information. Here you can upload your picture, enter the date of your observation, and localize it on the map if you do not have the GPS coordinates. Here you can enter what did you observed, and you can add any other additional information in those fields. Afterwards, you can submit your report. Once you have submitted your report, there is also the contact information of the person that will receive it if you want to ask any questions. Here is the map of natural hazards. This map contains very relevant information for the safe expansion of the communities by locating the actual and the potential natural hazards. The information you provide when you report an observation of a natural hazards on the territory help us to update these maps and make them more accurate. This map, as well as the report and other maps, are available on the web platform for all villages. We saw earlier where to download them on the website. I would like to conclude saying a big thank you for watching this video. If you are interested to learn more about the basic concepts of permafrost and its implication for land use planning, please watch our video Permafrost 101. And please join us for the question period. We will soon reach you to confirm the date and the time of this web meeting. Thank you, and hopefully talk to you soon.